Solar energy refers to the radiant light and heat emitted by the sun that can be harnessed and converted into various forms of usable energy. It is a renewable and abundant source of power that has the potential to play a significant role in addressing the world's energy needs while mitigating environmental concerns related to fossil fuel consumption and greenhouse gas emissions. Solar energy can be harnessed using a variety of technologies, with solar photovoltaic, PV, and solar thermal systems being the most prominent methods. Solar photovoltaic, PV, systems. Solar PV technology involves the conversion of sunlight directly into electricity using semiconductor materials, typically silicon. The process occurs within solar cells, which are grouped together to form solar panels. When sunlight strikes the solar cells, it generates an electric current due to the photovoltaic effect. This electricity can then be used to power homes, businesses, and even entire cities. Key points about solar PV systems include: types of solar cells. Different types of solar cells exist, such as monocrystalline, polycrystalline, and thin-film cells. Each type has its own efficiency and cost characteristics. Efficiency. Solar PV efficiency has been improving over the years, allowing for more electricity generation from a given area of solar panels. Applications. Solar PV systems can be installed on rooftops, solar farms, and even integrated into building materials like solar shingles. Grid connection. Excess electricity generated by solar panels can be fed back into the grid, earning credits or payments through net metering programs. Solar thermal systems. Solar thermal technology captures the sun's heat to produce thermal energy, which can then be used for various applications, including space heating, water heating, and electricity generation. There are two main types of solar thermal systems. Solar water heating. Solar thermal collectors. In this system, sunlight is captured by solar thermal collectors, often installed on rooftops. These collectors heat a fluid, usually water or a heat transfer fluid, which is then circulated through a heat exchanger to transfer the heat to water for domestic or industrial use. Concentrated solar power, CSP systems use mirrors or lenses to focus sunlight onto a small area, generating intense heat. This heat is then used to produce steam, which drives a turbine to generate electricity. CSP is often used in large-scale solar power plants. Advantages of solar energy. Renewable. Solar energy is a renewable resource, as the sun's energy is essentially inexhaustible on human timescales. Reduced greenhouse gas emissions. Solar energy produces minimal greenhouse gas emissions compared to fossil fuels, contributing to climate change mitigation. Low operating costs. Once installed, solar PV systems have relatively low maintenance and operating costs. Decentralized power generation. Solar panels can be installed at various scales, promoting decentralized power generation and reducing strain on centralized power grids. Challenges and considerations. Intermittency. Solar energy generation is dependent on sunlight, making it intermittent and requiring energy storage solutions for consistent power supply. Energy storage. Effective energy storage technologies, such as batteries, are essential for storing excess energy generated during sunny periods for use during cloudy or nighttime hours. Installation costs. While solar costs have been decreasing, the initial installation cost of solar systems can still be a barrier for some. Land use. Large-scale solar installations may require significant land area, potentially conflicting with other land uses. Future outlook. The solar energy sector continues to evolve with advancements in materials, manufacturing processes, and energy storage technologies. As these technologies improve, solar energy is becoming more accessible and cost-effective, driving its adoption around the world. Governments, businesses, and individuals are increasingly investing in solar energy as a sustainable and environmentally friendly power source. In summary, solar energy is a versatile and abundant resource with the potential to play a vital role in the transition to a more sustainable energy future. Its various technologies, coupled with ongoing research and development, have the capacity to provide clean and reliable power while reducing our reliance on finite fossil fuels.